Okay, I'm going to do 71 through the end. 71. 3 properties of metals that nonmetals do not have. High density, good conductors of heat, good conductors of electricity, solid at room temperature, so therefore high melting point. They generally have high luster. They are generally malleable. They are generally ductile. That's pretty much all I could think of. 72. What are valence electrons? They are the outermost electrons of an atom. Why do we focus so much on them? Because they're the electrons that are involved in bonding, and bonding is what gives every kind of chemical reaction. It's what allows all chemical reactions to occur. 73. Draw Lewis dot structures for the following: lithium, bromine, aluminum, neon, oxygen. So with this, you look at your periodic table, you have to identify the group, which tells you the number of electrons, and for this you should have them labeled 1A through 8A. Lithium is in group 1A, means it has 1 valence electron, 1. Bromine is in group 7A, 7 valence electrons, 1, 2, 3, 4, 5, 6, 7, so leave one of them blank. Aluminum is in group 3A, 3 valence electrons. Neon is in group 8A, 8 valence electrons, 1, 2, 3, 4, 5, 6, 7, 8. Oxygen is in group 6A, 6 valence electrons, 1, 2, 3, 4, 5, 6. When it comes to which one to leave blank, like sometimes I'll leave the top blank, sometimes the bottom, sometimes the side, or not blank, but like unpaired. It doesn't matter where you leave them unpaired, but you never want to pair up 2 of them if there's still a vacant spot. We liken it to like if you're getting on a bus full of strangers and you hate everyone, you're not just going to sit next to someone when there's an available seat. Basically, the bus is going to fill up with all individual people taking seats, and then once it's all full, people are then going to start pairing up. So what you don't want to do is aluminum like this. That's wrong. That's not going to happen. This one's going to go by itself. And the reason for this is electrons are negatively charged. Why would 2 negative electrons want to hang out together in the same orbital? They're not. So they're going to be in their own separate places until you force them to become shared like this. 74. Identify one element from each of the following groups. Alkali metals. That is group 1 or 1A. So not hydrogen though, that's a nonmetal. It's there because it has 1 valence electron, but is not an alkali metal. So you could say lithium, potassium, sodium, rubidium, cesium, or francium. Alkaline earth metals, that's group 2A. Beryllium, magnesium, calcium, strontium, barium, radium. Halogens, that's 17 or 7A. Fluorine, chlorine, bromine, iodine, astatine. And noble gases, that's all these at the end: helium, neon, argon, krypton, xenon, radon. $75. Would you consider these to be reactive? You may choose more than one. Which of these would you consider to be reactive? Okay, I consider alkali metals very reactive, yes, because they have 1 valence electron, and when you have just 1 valence electron, you're so eager to get rid of it that you'll dump it off on anything. So therefore they are very reactive. I would also consider halogens to be very reactive because they have 7 valence electrons. When you have 7 valence electrons, you're so close to getting 8, which is what you want, that you will steal that 8th one from anything. So very reactive. Noble gases, no, they have 8, or in the case of helium, 2. Either way, they have a full valence shell, they're done. No reactive, no reactivity. 76. Same question, but non-reactive. So again, noble gases, non-reactive because they have a full valence shell. They don't want to gain or lose any, so they just do their own thing. 77. Which ions do the following elements form? Beryllium has 2 valence electrons because it's in group 2A, it wants to lose both, so therefore, beryllium 2 plus. Oxygen has 6 valence electrons. It wants to gain 2 negative electrons, thus becoming a 2 minus charge. Lithium has 1 valence electron. It wants to lose that, forming Li plus. Krypton, trick question, it will not form an ion. It is done. It is a noble gas. Aluminum has 3 valence electrons. It wants to lose them, 3 plus. Nitrogen has 5 valence electrons. It wants to gain 3, thus forming N3 minus. Potassium has 1 valence electron, wants to lose it, K plus. Fluorine has 7, wants to gain 1, F minus. Na has 1 valence electron, wants to gain lose 1 valence electron, forming Na plus. And chlorine has 7 valence electrons, wants to gain 1, Cl minus. Complete the following grid. All right, so first we have to name. So the second one's going to be magnesium nitride. You just state the first element, change the second one to "ide." Magnesium nitride. If you go on to chemistry, there's a whole lot more rules. In fact, you can dig through my video history and find the more advanced rules for naming, but that's for next year. Third one down, we have sodium and chlorine. So we have to first figure out what the ions are. Sodium is Na plus. Chlorine is Cl minus. Note it's a nice easy 1-to-1. So we just call this NaCl, and that's going to be sodium chloride. Next one, aluminum and oxygen. Aluminum forms a 3 plus. Oxygen forms a 2 minus. We can't do a 1-to-1 here. What you're going to end up having to do is that crisscross rule. The 3 comes down here, the 2 comes down there, so we end up with Al2O3. That's called aluminum oxide. Potassium is K. Sulfur is S. K forms a plus charge, a 1 plus. Sulfur forms a 2 minus. Again, we can't do a 1-to-1, so we have to crisscross. So that 1 goes down here, the 2 goes down there. K2S, potassium sulfide. Calcium bromide is the next one, or calcium and bromine. Calcium is 2 plus, bromine is 1 minus. We just write the minus. Crisscross rule, end up getting Ca, Br2, calcium bromide. And the last one, strontium and oxygen. Strontium is 2 plus, oxygen is 2 minus. So the crisscross rule would say Sr2O2, but we're going to find the simplest ratio of that. Or in other words, it's just a 1-to-1 ratio. So this is going to form SRO. Again, you don't want to say Sr2O2. That's not correct. It's just going to be SRO, and we call that strontium oxide. 79. Name the following covalent molecules. So with this, you have to know your prefixes, Greek prefixes. So the first one is going to be carbon tetrachloride. The second one, phosphorus trichloride. Then we have nitrogen dioxide. Then we have carbon monoxide. Then we have dinitrogen tetroxide. You don't say tetroxide, you just say tetroxide. Then we have sulfur hexafluoride. And finally we have nitrogen pentafluoride. Number 80. When the following elements bond, will they form I ionic or C covalent? Now the idea behind this is for ionic, it's going to be a metal plus a nonmetal. For covalent, it's going to be a nonmetal plus a nonmetal. If you get metal plus a metal, check again because you did something wrong. 2 different metals are never going to just bond together. Okay? So, sodium and nitrogen, metal, nonmetal, ionic. Nitrogen and iodine, nonmetal, nonmetal, covalent. Aluminum and bromine, metal, nonmetal, ionic. Sulfur and oxygen, nonmetal, nonmetal, covalent. Phosphorus and fluorine, nonmetal, nonmetal, covalent. Potassium and oxygen, metal, nonmetal, ionic. 81. Balance the following formulas. All right. Well, that's a 3. This one's very straightforward. Oh, sorry, no, not so much anymore. All right, I'm going to start with my chlorines. So I have a 2 and a 3, so let me put a 2 here, that gives me 6. Let me put a 3 here, that gives me 6. And now I have 2 irons, we're done. Not 82, but just the next problem. S8 plus O2 yields SO2. Okay, so O is done, but S is not. So I have 8 sulfurs. Let's do 8 sulfurs. That gives me 16 oxygens. So just an 8 there now gives me 16 oxygens, and we're done. Next one, C6H12O6 plus O2 yields CO2 plus H2O, basic combustion reaction. With this, my advice is to leave oxygen last because it's by itself here. But you always need to make sure you have an even number of oxygens on this side because there's no physical way you can have an odd number of oxygens when you have O6 and O2. All right, so let's see. I see a 6 here for my carbon, so let's just make that a 6. Okay. Hydrogen, I have 12 here, so let's make that a 6 as well. So we're good on C and H. And now let me count up my O's. Now, again, I need an even number of oxygens on this side because of the O2. So that's 12 oxygens. That's 6 oxygens. So altogether we have 18 oxygens. We're good, even number. So 18. 6 of them are here, so that means I need 12 more. So let me put a 6 there. So 1666. Next, ZNS plus ALP yields ZN3P2. That is, I think, a typo. Yeah, that's not the proper molecule because zinc always forms a +1. Let me change that real quick. I'm going to have to make a note of that. ZN3P plus Al2S3. Alright, so I'm just going to choose to start with my sulfurs. You can kind of start wherever you want. So let me do a 3 here. So 3 zincs are good, 3 sulfurs are good. So I'm good there. And 2 aluminums. Now how did that work before? 3 zincs, 2 phosphorus. Two aluminums. Oh, I see what's going on here. That's not where the typo is. This doesn't exist either. I'm going to have to scratch this one or change it. Zinc always forms a +1. So zinc can never bond to a sulfur as ZNS. The way this really should look is like this. ZN2S. ALP works because P is 3 minus and AL is +3. That works, and this now works. So let me redo this. All right. Let me start with my zincs. Let me do a 2 here and a 3 here. So 6 and 6 for my zincs. So now I have 3 sulfurs and 3 sulfurs. We're good. 2 phosphoruses and 2 phosphoruses. Good. 2 aluminums, 2 aluminums. That's how it should be. 81, or still on 81, the bottom one is H2O2 yields H2O plus O2. Alright, hydrogens are good, but oxygens are not. I have 2 oxygens, now I have 1, 2, 3 over here. So, let's see. I could tell right away I'm going to need a 3 there. Let me just talk through my logic. If I have 1, 2, 3, this needs to be an even number because I have O2 over here. So to make this even, let me put actually would a 2 work? Let me try this. 2 here gives me, yeah, that'll work. 4 hydrogens and 2 oxygens. So here's my 4 hydrogens. So let me count my oxygens. I have 4 here, 4 here. That works. All right, 82. What is the basic formula of a combustion reaction? You have a hydrocarbon plus O2 yields CO2 plus H2O, 2O. And this gives off a lot of heat. That's why we do it. Hydrocarbons are long chains of hydrogens and carbons, or I should say large chains of carbons with hydrogen sticking off of it. And it's what makes up natural gas, it's what makes up oil, it's what makes up coal, it's what makes up wood, it's what makes up a lot of plastics, polymers. And you take it and you burn it. You need a little bit of initial heat, but the heat you get out of it is a lot more. And this is why you're watching a video, because humans figured out how to put a little bit of heat in and get a lot more heat out. Otherwise, you'd still be sitting there and I'd be writing on a chalkboard for you. What I'm getting at is this has driven technology and driven society over the last few hundred years. 83. What effect has trillions of combustion reactions of coal, oil, and natural gas by humans over the last couple hundred years had on climate, and why? Well, again, we have hydrocarbons plus O2 yields CO2 plus H2O. What do we recognize about these two greenhouse gases? But the H2O, it's part of the water cycle. It's not really that harmful. The dangerous one that wasn't there before is CO2. So every time this happens, every time you burn coal, every time you burn every time you burn natural gas or burn wood even, you're releasing CO2, and the more CO2 we have in the air, the warmer it's going to get. So that's the effect. That's the main reason behind global warming. And that's the end of the review packet. Thanks for watching.